So welcome to section 11.1. This is a very familiar type of section that we're dealing with, and I just thought one example could do its purpose. You have some 2 by 2 systems that are before this problem, and those are easily done through substitution and elimination, but I thought I would just do a video on how to do it a 3 by 3, and we naturally use substitution. I'm sorry, we naturally use elimination. Wrong word there. It's funny. So I'm going to label these out as equation 1, 2, and 3 so you know what I'm talking about. But if you remember our goal is to solve for x, y, and z. And the way that we do that is we add a couple of equations together so that one variable drops out so we can turn it into its 2 by 2 system. And so as we look at this, maybe I'll take equation 1 and add it to equation 3. If I do that, I get a nice 6x, no y's, and I get minus z is equal to 8. The other thing that I could do is merge together another 2 so that the y's drop out again. And so why don't I take number 2 and add to that 3 times equation 3. So equation 2 I'll just rewrite. 2x minus 3y plus 4z is equal to negative 15. And I'm going to triple equation 3 and get 15x's. And then I'm going to get 3y, that's why I'm doing it, is so that those balance, minus 6z is equal to 36. And if I add those together, I get 17x's, no y's, minus 2z is equal to, it looks like 21. And so now I'm going to solve this new 2 by 2 system. The 2 by 2 system that consists of 6x minus z is equal to 8, and 17x minus 2z is equal to 21. So you could do this either by substitution or elimination. I'll just keep with the elimination. I'm going to go ahead and multiply that top equation by 2. And if I do, I get 12x's minus 2z's is equal to 16. And here I'll just bring this one over. 17x. Now I'm seeing something that I wasn't quite right? I got the numbers to match. Unfortunately, the signs don't match. So let me multiply by negative 2. And I'll just go ahead and change all those signs to negatives. So when I add these together, I get 5x's. And over here I get 5. So I get the nice answer of x equals 1 for this number 52. Now that I know x is equal to 1, I can easily get z. I can say, well, 6 times 1 minus z needs to be equal to 8. I'm getting that from right here, right? And so 6 minus z is equal to 8, or z is equal to negative 2. So that's great. So now I know my solution so far. It's a 1, something, and a negative 2. I can go to any of the original equations to find out what y is. So let me scroll up to the original equations. Maybe I'll use that last one, the one where y is all by itself and positive. So I'm going to use the 5x. So that's 5. I was going to write x again, so let me erase that. So that's 5 times 1 plus y, that's what I'm looking for, minus 2 times negative 2, that needs to be equal to 12. And so now I have 5 plus y plus 4 is equal to 12. And so I have y plus 9 is equal to 12, so obviously then y is 3. And we can finish the problem by coming right up here and saying, oh, the solution is 1, 3, negative 2. That'll be your common experience as you go through any of the 11.1 problems.